Okay, so let us solve a few problems from problem sheet 1. So from each problem, I will select like one or two problems to solve. So as you can see in problem 1, we have find the first four non-zero terms of the Taylor series of the function about 0. So this is a very basic question, and for this one, we are going to use the actual formula for the Taylor series. And like you can apply other formulas, but if it is not explicitly mentioned in the problem, then always you have to apply this basic formula, which is f of a plus f prime at a times x minus a, and obviously divided by 1 factorial. Okay, and second prime divided by evaluated at a divided by 2 factorial x minus a squared, and third derivative evaluated at a 3 factorial x minus a cubed, and fourth derivative evaluated at a 4 factorial x minus a to the 4, and so on. So if we are going to pick any one of these, like the first one, you will start with a function that is 1 plus x to the 3 halves, and you find its first derivative. Like we need at least 4 derivatives because it is asking give us 4 non-zero terms. So it will not be the case with the function like sine of negative x, because you know that like some of the terms are 0. Then for this function you need more derivatives, like maybe 6, maybe 8 derivatives. But for this one, we need like at least 4 derivatives. So the first derivative is you can take this exponent down and subtract 1. It's going to be 1/2. And obviously, like you need to multiply the derivative of this inside function, but the derivative of this guy is 1, so we are not going to multiply that. The second derivative is 3 halves times 1/2. And again, you subtract 1, that becomes a negative 1/2. And the third derivative is 3 halves times 1/2 times negative 1/2, 1 plus x to the negative 3 halves. And fourth derivative is 3 half times 1/2 times negative 1/2 times negative 3 halves, 1 plus x to the negative 5 halves. So once all the derivatives are done, you can take these all the derivatives and evaluate everything at 0. So if you put 0 in these all the terms here, 1 plus 0 is 1, and 1 to the something is again 1. So these all the terms will be equal to 1 if you put x is equal to 0. The only thing that is left is the coefficient. So the coefficient in this case is 1 because this guy is 1. This guy is 1, so the coefficient is 3 halves. So f prime at 0 is 3 halves. If second prime at 0 is, like, just multiply these two, 3 over 4, and just multiply these three. So the third derivative evaluated at 0 is negative 3 over 8, and fourth derivative evaluated at 0 is negative 9 over 16. So you just multiply these all numbers. Now we'll just take these all the things and put it in this formula where we are substituting a is equal to 0. So everywhere a is equal to 0, and we are going to substitute the values of these all the derivatives. So a function which is 1 plus x to the 3 halves is equal to f of 0, which is 1. And then the second term is f prime at 0, which is 3 halves. So this is 3 halves times x minus 0, but x minus 0 is x, plus the second derivative is 3/4 divided by 2 factorial. So you can write it like multiplied by 1 over 2 factorial x square, The third derivative is minus 3 over 8 divided by 3 factorial x cubed. Fourth derivative is minus 9 over 16, 1 over 4 factorial x to the 4, and so on. So once you simplify, this is 1 over 3 halves x plus, you can simplify this guy, 4 times 2 is 8, x square minus, this can be 1 over 16 x cubed minus, this is 3 over, what's that? Because 4 factorial is 24 and divided by 3, it's 8. 8 times 16 is, I don't know, maybe 128 x to the 4 minus and so on. Because the next term would be negative. But doesn't matter. So these are like, So the question is about find 4 non-zero terms. Maybe we are doing one extra because we have to go only till 3 derivatives. So because that's why we don't need this term. Maybe we don't need to add this term, but it's all okay. Like if you're adding one extra term, it doesn't matter. So this is how you do whenever you're asked to do any Taylor series, and we have to do the same thing here. Find the first 4 terms of the Taylor series of the function around point A, and point A is given to us, which is this one. Okay, so this is also simple, but the thing is that, so I'm not going to do this problem. Like this is going to be x minus whatever the value of A. So always you will see x minus pi by 4, and in the next term we have x minus pi by 4 squared, and there's some coefficient here, and then the next term is x minus pi by 4 cubed, and then coefficient, and then similarly we have a couple of other terms. So in everything you have x minus whatever the value of A is, as you can see here. This is the only difference. And then you find the function in the derivative, you always evaluate that thing at A. So in this problem, we evaluated at 0. And you know very well, this is also called Maclaurin series. Okay, so second problem, very similar to the first one. That's why I'm not going to do it. So the third problem is use a non-Taylor series, find the first 4 non-zero terms of the following series about 0. This is a very good question, and this is a very interesting question because you have to use some non-series to find the series of these all the functions. So you can start with anything that you know. For example, I can pick any problem here. For example, this third one looks very good to me. You start with sine x, that is x minus x cubed divided by 3 factorial x to the 5, 5 factorial, and so on. This thing you should know. And then you replace x by 3t. So I'm going to write here replace x by 3t. And once you do this, will happen. So 3t minus 3t cubed divided by 3 factorial plus 3t to the 5 divided by 5 factorial, and so on. If you want to simplify, you can, but it's better to simplify. So 3t minus, you can write this thing 3 cubed t cubed over 3 factorial. If you don't want to simplify further, 3 to the 5 t to the 5 5 factorial, and so on. Now you simply multiply by t to find the series that you're looking for. Okay, so if you multiply by t to the both sides of this equation, like sine 3t, like this one, then you are multiplying t on both sides. The first term would be 3t squared minus 3 cubed divided by 3 factorial t to the 4 plus 3 to the 5, 5 factorial t to the 6, and so on. Because if you multiply, you're going to add the exponent. So yeah, this is it. This is a series. That's it. You can see it's very simple problem. You start with some non-series and you replace the argument with something else, and you multiply something, you divide something to get what you want. So for this one, maybe I'm going to give you a hint. Start with e to the x, start with 1 minus x, square root of 1 minus x. But if you don't know this thing, you can always find this thing by using, like, this one can be found by using binomial series. And for this one, start with cosine x. For this one, start with log 1 minus x. For this one, yeah, maybe this is a problem. Sine inverse of x. Yeah, for this one we can integrate. Like we can integrate. You know very well. Like you can start with 1 minus x and replace x by x square, 1 minus x square, and if you integrate, like whatever the series you get, you integrate both sides. This integral is sine inverse x, which is log sine x, and whatever integral this guy will give you is the series for this one. So yeah, but like maybe exclude this problem for now. And yeah, and 7 1 is you start with maybe 1 over 1 plus x and use binomial series for this one, and then replace x by negative z square. And for this one, I would suggest write this in this form: z e to the negative z square. This problem is very simple. You start with x and replace x by negative z square and then multiply by z. That's it. Very simple. Yeah. So once you do practice on these all the problems, it would be enough for you to like do your exam and understand all the problems in your exam. And this fourth one is simple too. Like you start with some known series and like, for example, for this problem, we know that what is cosine t equal to for the second problem. So cosine t is equal to, no, it's 1 minus t square plus t to the 4 divided by 4 factorial, sorry, and so on. Okay. And e to the t is 1 plus t squared divided by 2 factorial plus t to the 3 divided by 3 factorial, and so on. If you're going to multiply these, you just need to multiply both of these series in this way. So one series and another series. One series is e to the t is 1 plus t squared divided by 2 factorial plus t cubed divided by 3 factorial, and so on. And this one is 1 minus t squared divided by 2 factorial, t to the 4 factorial, and so on. When you're multiplying, you always start with the smallest powers. Like I'm starting with constant terms. If you multiply 1 with 1, you will get 1. That's a constant term. And then you always start with the terms that involve only t. Like if you multiply 1 with t square or t to the 4, this will always be an exponent which is greater than 1. So I'm going to start with multiplying t with 1. So t with 1, this guy is giving me t. Now just find another pair which gives you t, or like maybe t to the 1 times some coefficient. So you can see there's no any other term like that. Now I'm going to start with the second power. Like now you can see you take this one and multiply with negative t square over 2 factorial. You will get negative t square over 2 factorial. And then what other thing will give you this t square that you can see is multiplying this t square over 2 factorial with this one. It will be plus t square over 2 factorial. Now for the cubic one, you can see one way is like I'm choosing a different color. Multiply this t with this t square. So it will be negative t cube over 2 factorial. And then multiply this t cube over 3 factorial with 1 to get t cube 3 factorial, and so on. So I'm chopping it to cubic power. Then you can see like these terms can be cancelled. And then for this, you can simplify, like you have negative 1 half plus 1 over 6. So it would be negative 2 over 6, which is negative 1 over 3. So it's going to be 1 plus t cube divided by 3. It's negative 1 over 3. That's why I'm writing negative here, and so on. Okay. So this is their product. Like you need to combine the terms, the constant terms, the terms having t to the 1, t squared, t cubed, and then add or subtract these terms having the same powers and keep others same. This is how we find this like product of two series that you can see in all of these problems. In this one, you start with the series of this one and this one and then multiply. And this one, you start with 1 plus x and then replace x by sine theta. And like we have done this problem in class. So this is a class activity, I think, as I remember. Yeah. And yeah, this can be done in a similar way too. Okay. This is a very simple question where we have to just match some series, and I think uh, like you know how to do this problem. Like for sine x, you know very well that's going to be only odd powers. So maybe what should I do? Like this is number one, and the series for this one is d. So I'm going to write d in front of this one. And for e to the x, the series is, you can see this one. This is just you have to identify the right series, and I'm going to write in front of this one, I'm going to write a, which is done. Sine of negative x is just take this series of x, sine x, and replace x by negative x. You will get this one. So I think these are same. And cosine of negative x, this guy is you take the series of cosine x and replace x by negative x. The series for cosine x is this one. If you replace x by negative x, you take negative x squared, the negative vanishes. Negative x to the fourth. Since these are even powers, the series of cosine x should be same as the series of cosine negative x because these are only even powers. So cosine of negative x is e. So e is done here. And cosine of root x is like you take the series of cosine x, which is 1 minus x square, and you replace x by root x. So this is like root x squared, root x to the 4. Now if you want to simplify this guy, this is 1 minus x over 2 factorial plus, now you can see like 1, 2 will be cancelled from here in this one, and there will be only 2 left, or 4 factorial minus and so on. So this should be, yeah, g. So cosine of root x is g, and 1 over e to the x is equal to e to the negative x. So the series for that one that I can see is this b. So I'm writing b here. And for e to the negative x square is the remaining series, which is I think this one. Yeah. Okay, so like you'll be asked some multiple choice questions based on the series like this. You can understand these things are really simple. If you know just the basic series, you can do these all the questions easily. So in this one, we have to find the error bound. Find a bound for the error and approximate inequality with a third degree polynomial. So we have to find E3 of x for the polynomial given function about x is equal to 0. So this is like we have to find the actual error, and then we have to find the bound for the error. So actual error would be the actual value of the function minus the third degree polynomial. So if you pick this problem, or maybe you pick any other problem, E3 evaluated at 0.1 is equal to the value of the function, which is e to the negative 0.1. But I think there's discrepancy in these two. This is e to the negative x and this is e to the 0.1. Yeah, it depends. Like you take this function e to the x and take this value to be negative 0.1, or take the function to be e to the x and take the value to be e to the 0.1. This is good. This is good, I think. So e to the 0.1 minus p3 of x, which is 1 plus x squared divided by 2 factorial, x cubed divided by 3 factorial. Okay. I'm going to write things now. Now I'm going to replace the value x with the value e3 of 0.1 is e to the 0.1 minus 1 plus 0.1 plus 0.1 square plus 0.1 cube. Now you can find what this error is. Okay, you can simplify and find error. Now what is the error bound? The absolute value of the error en of x should be bounded by this m should be smaller than or equal to n plus 1 factorial x minus a to the n plus 1. Now I'm going to replace n by 3. So this is 3, this is 3, this is 3, and a is 0. And x is any point within the interval that you're estimating. And how to compute the value of m? It's just the maximum value. Let's say we are saying that x is between -1 and +1 because 0.1 belongs to this interval. You can pick any interval if it is not given to you. So n plus 1 derivatives of the function, absolute value of that. So you have function e to the x. If you take its 4 derivatives, it's again e to the x. And the maximum value of e to the x in this interval is always this value at the 1. So it's e to the 1, which is equal to e. So you just put everything here. So e3 of x should be smaller than or equal to value of m, this guy, n plus 1 factorial, which is 4 factorial. And this is like 1 minus 0 to the 4. And if you simplify everything, this is going to be, simplify in the sense like e divided by 4 factorial. Now you can find this number, e3 of 0.1, if this number is positive or negative. You will always see that e3 of 0.1 in the absolute value sense is always less than or equal to this error, like e3 of x that we have found, which is e divided by 4 factorial. Like you can find the exact value after like simplifying and find the exact value of this one, and you will see that this is the maximum error bound, and this error must be less than or equal to this guy. Okay, maybe the last problem that I'm doing, and last problem of this first sheet. So for all of these, the Taylor series is an alternating series, and you know very well for an alternating series, the error bound is given by this guy. We know this thing. Okay. You have to know what is this n here. This is a bit tricky because the n from the polynomial is not same as n here. The Taylor series converges to f of x. Find the smallest constant k given by the alternating series error bound. E4 of 1 is less than or equal to k. So E4 of x is always equal to the actual function minus the which guy? Nth degree polynomial, like 4th degree polynomial of x. This is always defined in this way, as we know. If you take the first thing, which is f of x is equal to e to the negative x, maybe I'm taking the second one. The series for cosine x is this guy. 1 minus x square So you can see this is the degree 4 polynomial because the maximum degree is 4. So this is degree 4 polynomial. But if you take this guy, maybe let me write x to the 6 divided by 6 factorial. This is called S3 because this is only sum up to 3 times. So S minus S3 should be less than the fourth term. So I have to find out the error between actual function, which is cosine x, and this guy. It should be less than whatever the fourth term is. So S minus S3 should be less than A4, which is what? Which is x to the 6 divided by 6 factorial, but its value evaluated at 1, as you can see here. The value is evaluated at 1. Okay, so this should be 1 over 6 factorial. So this error, whatever it is less than or equal to 1 over 6 factorial, which is 0.00 something. I don't know, you can see, but like you do not need to simplify beyond this. This is how we do it by using an alternating series error. Okay, so that's it.